Hey guys, my name is Mackenzie Brooke, and I am one of the regional STEM coaches in the professional development department for STEMscopes. And today I'm going to walk you through one of our Explore activities. It's actually a TUVA called the Cycles of the Moon, Earth, and Sun. And this comes from our Earth, Sun, and Moon system scope. So today, to get here, what you're going to do once you're in this scope in the Explore, it's actually our fourth Explore here. And I'm going to walk you through how to use this TUVA dataset, how students can actually go ahead and manipulate some data. So the first thing I want to show you over here on the right-hand side, this is where you're going to find your print files. So I just clicked on this first one. You'll see it over here on the right side of my screen. And as I scroll down, you're going to see this everyday phenomena. So this is the learning target for this activity. And we're going to have students figure out how can we predict eclipses and number of daylight hours. So as I scroll down, this is the full entire lesson plan. But to kind of start off, I'm going to just follow us through the cycles of the Moon and Earth system. So when we're thinking about this data set, it does have information about the duration of daylight, lunar and solar eclipses, seasons, and the phases of Moon from 2014. So this data set actually comes from the US Naval Observatory. And in this first part, we're going to look at eclipses. So eclipses occur when something during their orbit, the Moon and Sun form a line with the Sun. There are two different types of eclipses. We have lunar and solar. So the first thing we're going to want to do is we're going to drag time to the x-axis. So I'm going to go ahead and drag that in. And we're also going to drag in moon phase to our y-axis. Right, so we're going to notice this data is now being manipulated. All right, so we can make some observations here. So just to kind of kick things off, I'm going to click on Eclipse. All right, and I want you to now think about how many eclipses happened in the year 2014 in the Northern Hemisphere. So go ahead, pause this video, and think about that answer. So now that you can see, we actually have 4 eclipses. So you see these 2 are red. That means it's a lunar eclipse. And the 2 down here that are green, those are solar eclipses. All right. So if you guessed 4, that is correct. And then if you went on to the second question here, how many were lunar, how many were solar, I just kind of gave you the answer here, but we have 2 lunar and 2 solar. So now I'm going to ask, what was the phase of the moon when the lunar eclipses occurred, and why might this be so? Go ahead, pause your video and answer the question. Once you get here, if you notice the new moon down here, right? This, you see, if I actually scroll over this eclipse, you'll see it's in the moon phase new moon, as is this solar eclipse. And then the lunar eclipse, these are actually going to be during the full moon. Okay. So now I want you to think about, why are there so few eclipses in 2014? Shouldn't there have been a lunar eclipse every month? So go ahead, pause your screen here and think about why there might have been so few eclipses. As I scroll down, okay, you'll notice here, so the moon's orbit around the Earth is actually tipped about 5 degrees to Earth's orbit around the sun. This means that the moon spends most of its time either above or below the plane of Earth's orbit. So that's why there's very few eclipses that occur every year. So I'm going to go ahead, we're going to pause here, and we'll pick up with part 2, which is our seasons. So we're going to now want to investigate how the hours of daylight in decimals in Washington, D.C. in the Northern Hemisphere vary each season using a scatter plot or a line chart. All right, so what I'm going to do, I'm going to go ahead and reset. All right, and so now we'll want to see hours of daylight. So we'll drag that to the x-axis. Then we're going to drag season to the y-axis. Okay, what do you guys notice? Go ahead, draw your graph that was plotted here in the space below. The next question, so let's think about which season generally recorded the maximum daylight hours. Okay, so go ahead and think about the maximum daylight hours. If these are hours of daylight, which season had the most? If you guessed summer, you'd be correct. And then think about which season generally had the minimum daylight. If you guessed winter, you'd also be correct. So you see these data points here, they scatter kind of down on the left side of this graph here. And actually, if you want to go ahead, you can look at a scatter plot or line chart. So I go to my graph section here, I can go in, I can look at a line graph, right? Or I can also look at a scatter plot, which is what we had before. So the last question, how do daylight hours vary over time? I want you to think about how this trend can be described. So as I scroll down here, you'll see daylight increases throughout the spring and most of the summer. After it hits the highest point in summer, the day length begins to decrease. The days continue to decrease throughout the fall and most of the winter. After it hits its lowest point in the winter, day lengths begin to climb again through the spring and the summer. So if you picked up any of those trends from this plot here, that's awesome, congratulations. And I hope that after all of this, you were able to come up not only with looking at a bit more of some patterns that you might observe with this data manipulation tool of our tuba data set, but also just learning a little bit more about the moon, earth, and sun system. So from here, if you had some fun doing this explore activity, I do recommend coming back up. Feel free to fill out this claim evidence reasoning, this activity here. And also, why don't you go ahead, actually, let's open this up. So if you open up the claim evidence reasoning, right, go ahead and write a scientific explanation about how day length is related to seasons. All right, so use the embedded data set in order to provide evidence in order to support your claim. If you need a little help with your reasoning, I do recommend in our Explain tab, looking at that content connection videos, what are eclipses, that will provide you with a bit more information about the scientific reasoning behind the evidence you might have found within this data set. Thank you all so much for joining in today, and I hope you enjoyed this as much as I did. Bye.